Well, first of all, thank you very much, AnyLogic, for inviting us. And hello, everyone. It's good to see some familiar names. So today I'm very happy to be presenting one of the use cases that we have developed here at Petronas, which is basically a simulation of the inventory and primary logistics management for refineries and depots. So before we get into that use case, I would like to explain a bit how Petronas is structured. Then we're going to be going through the problem statement, giving a giving an overview of the solution, explaining the architecture and the key features, and then we're going to end with the benefits that we brought with this solution, and finally some conclusions, as well as how we are leveraging on AnyLogic. But before I get into all those details, I would like to introduce myself and my colleague here. So I've been developing models with AnyLogic for almost 10 years in many different industries, including like oil and gas, pharmaceuticals, car manufacturing, logistics, airports, finance, and others. And everything has been done mostly within AnyLogic. I'm originally from Spain, from a small island. And here with me, I'm very proud to introduce Ira, local from Malaysia. So Ira, please.
Hi everyone. My name is Ira. So I'm data scientist with 2 years experience. I work on optimization project in oil and gas industry. So nothing much about me. So basically during my free time, I love spending quality time with my loved one. Or maybe sometimes I will spoil myself by going to spa.
All right. Thank you, Ira. So as I was saying before, first of all, I would like to explain how the Petronas is structured in terms of digital products. So there is this unit or this company under Petronas Holdings called PTSB, which stands for Petronas Digital. And this was set up about 6-7 years ago when Petronas decided to set up a team that would look after all the digital solutions across the company. And within this big group, there are different other layers, which I'm not going to get into the details, but one of them is the data science. So this data science team is about 130 or so people. It's probably one of the biggest, if not the biggest, data science center in Southeast Asia. So within the data science department, we have different areas which cover advanced machine learning, computer vision, NLP, and of course now Gen AI. And then one of them is optimization and simulation, which we keep together. So this area, although it's not a hype work board, like optimization and simulation has been there for many years now, still is actually one of the major contributors for value savings and value generating in the company. Also, we've been using AnyLogic as an ideal tool for integrating other solutions like optimization, machine learning, and now we are even doing exciting things with Gen AI, integrating it with chats as an additional tool that can be used for performing certain tasks. In terms of when I joined Petronas as a simulation expert, I honestly didn't expect that I would be able to develop simulations in so many different areas. So we have developed models in logistics, as I will be presenting today, but also in terms of refinery processes, energy, even pedestrian flows. So as I was anticipating before, one of the model among many others that we have developed was focusing on a small portion or a portion of the value chain. So why is a challenge? Well, because there are many uncertainties at various stages of the value chain, which propagate, as you can imagine, in any value chain, downstream the chain. So in this case, we were, or the chain was starting at the refinery. So we were modeling the different production of products and storing of those products, together with the imports, which were arriving by vessel. Then this product is later distributed to different locations in Malaysia. So for those that don't know, Malaysia has a peninsula, but also it has a few regions in the east. So they are communicated by vessels, which is what we call primary logistics. Also from the refinery, there are deliveries by pipeline. So there is an airport which is kind of close to the refinery. So some products are delivered to the airport by pipeline. Then there's also truck lifting, and there's also exports. So all of this is located at the refinery site. Then once these vessels travel to the different locations or the different depots, it's stored in tanks. But these tanks sometimes are also not just owned by Petronas, they are joint ventures with other oil and gas companies. So these other oil and gas companies will also bring additional products to these locations. And finally, it's the lifting of these products by truck again, which would be the end of the chain. So again, as I was saying before, this is a challenge because of the uncertainties. So many of the uncertainties will come from delays in production, for example, or changes in the production at the refinery side. Then there's also vessel delays, so or advances, normally delays, which can affect the inventory, as you can imagine, can affect the inventory at the depots. There's the biggest concern of the planners is to avoid tank tops. A tank top can happen if you bring a vessel too early and there isn't enough space in the tank for the cargo to unload. So it has to leave with a volume in the tank. So that's a value lost. Then also the demand is uncertain. So sometimes you might get more lifting, sometimes you might get less. So that of course will impact the inventory levels. In addition to this, the vessels can carry or will carry multiple products, and they don't just go from refinery to depot. They can also do multi-drop, which basically what that means is they will drop one product at one location and then travel to another location. So this is again a high-level view of the problem, but of course that there are a lot more details that I'm not going to go through it today. So hopefully everyone gets a picture of it. So how did we approach this problem? So basically, the main idea was to develop a simulation so we could identify what the bottlenecks are in the system. So we have this depot and refinery, which are pushing and pulling. And then we have the inventories, which are basically some sort of way of handling the uncertainty. So how does this model work? So we have the simulation model, which is being fed by an Excel file. But this Excel file is actually being automatically created by pulling data from different sources. So these different sources are basically opening stocks, lifting profile forecast, vessel routing plans, and refinery production plans. So all of these are uploaded into the system, which is then pulled and converted into Excel. Why Excel and not directly into the simulation model? Well, because the simulation model actually allows the user to run different what-if scenarios, and we thought that Excel is actually a good user interface for the user to change values and create different scenarios. Just one additional note. So this model is actually generally running for a month. So the vessel origin, the initial vessel plan is created or generated by an optimization model. So this optimization model then is fed into the simulation, which is basically going to validate the results of the optimization. So optimization, as you know, or if anyone has had any experience with it, it can be so it's an MILP model, mixed integer linear program, which means that there are some challenges when you are trying to model real use cases, because MILP assumes that the problem is it can be modeled linearly, but that's not always the case. So sometimes there are certain assumptions that you need to make or certain simplifications, which is not the case in the simulation model, where we model the actual the system as it is. So my point here is that the simulation can be used as a validation tool for the optimization. Plus, it can handle the uncertainty, which we will be explaining later. So once we have this model, which pulls the data from these different sources, it will generate the results. So we allow the user to access this model through a custom web application. So this web application has some UI buttons and options that can be set. And then it also has the interface that we will be sharing later of the simulation model. So this is all done using the AnyLogic Cloud API. In addition to this, we also have a daily task, which is running in the backend automatically, again, also using the AnyLogic Cloud API. Basically, what it will do is it will every day in the morning, we will automatically pull all this data from these sources, and it will run the model for the next month, and it will generate an output report with highlighting the different flags or problems that you might encounter, and then it sends this automatically to the planners via email. All right, Ira, now this is to you.
Okay, hi, hello. So I will be covering the simulation overview, where we have two types of view. One is map view and the other one is a summary view. So as you can see here, we add the snippet from our simulation. So the simulation planner dissemination enables planner to access the strengthen the resilience of their plans for the upcoming month. So for the map view, the first view is the map of the if you move back, Mark. Okay, so the first view is the map of Peninsula and East Malaysia, where we can see all the location of the depots and the refinery together with the vessel delivers. So in this view, the user get the summary of potential warning or critical events. So for example, in case of high critical, we have um, the depot locate with highlighted in yellow colors. So if you click on that, um, okay, so once the critical location has been identified, the user can click and access the depot view, which offer more detailed insights such as tank levels, product lifting profile, and also inventory level for each product. And also we can even display a more detailed breakdown of certain data related to a specific product. For that, the user can click and access the table. So all these results can be exported into an Excel format. So next, we can move to the summary view. So if you click, maybe you can move forward to the summary view.
Give me a second because I don't have that much to control. All right, coming up now.
Okay, so for the summary view, the dashboard has been structured in three areas, which are mass volume view, stake chart view, and also key performance indicator. So for the first one, for mass volume view, as you can see here, this view offer, if maybe you can stop for mass balance view. This one. Okay, so for mass volume view, so this view offer aggregate numbers for all the stages model in supply chain given a product and a date. So the user can select the desired product and date. And then for the second one, for the stack chart view, um, so for the stack chart view, this view gives further insight on the different value change stages. So it offers stack chart view for the selected date. So it is possible to click and view the volume levels over time as well as the moving average. And the last one is the key performance indicator. Like below. Yeah, this one. So for the key performance indicator, this view shows the main critical event that occur the periods. For example, the number of tank top. So how do planner use the simulation to generate a reliable plan? So we have three steps to follow. For the first one, the user can run the simulation with the data extracted from the sources. And the second one, the user can identify the potential problem, which they can make some modification to the input file, like adjust the vessel unload date to ensure avoidance of time critical levels. And the last one, once you are happy with the given plan, you can proceed to run a Monte Carlo experiment. So next slide. Okay, so next one is what is the benefit of our stakeholder? So the first one, so thanks to the automated data pooling, the planner can get a view of the next 30 days value change outlook in matter of seconds. So before this, the process would take up to hours to pull and compile all the required data. So now they get an email every morning with forecasted outlook. And the second one is before this dissemination exists, there was no way to measure risk. So with Monte Carlo experiment, planners now can quantify a plan resilience, which overall reduce the cost to mitigate the critical event. And the third one, the simulation now is used as a big orchestrator of the system that combines data with the business knowledge and processes. So this has improved the communication between the different units, for example, refinery and depots. And the last one, the simulation offers metrics that didn't exist before, such as mass balance. So the planner can now know the volumes for each products and date at each stages of value change. And then next slide, Mark. Okay. For conclusion, so some of the learning from the building supply chain simulation. The first one, customer lifting at depot is the most uncertain stage in the supply chain, and mitigation involve difficult changes at early stage upstream. So to be able to have more accurate simulation, there's an effort to develop machine learning models that predict lifting volume with more precision. And the third one, the second one is request from the business is to be able to develop an optimization layer that automates the adjustment of vessel. And the last one is planner would like the model to be further expand to include more feature of the value chain, such as vessel maintenance, availability, and compatibility. I think that's all from me. I'll pass back to you, Mark.
Thank you very much, Ira. So finally, we would like to have a few words on why we chose AnyLogic. So as I was saying, I've been working for 10 years already, so I've had time actually to work with other tools as well. So one of the benefits that we get from using AnyLogic is that it uses Java as the core language. So just to share an experience that we faced when building a model, an optimization model using another language. So we built this system using Python, which is the most used. I'm assuming is the most used language now. But when you are building at a very low level, Python is not a language that performs, I would say, well at all. So we had to actually migrate most of the stuff to Java to recover the performance. So again, it's a great language for performance. Then it's also been there for long enough that there's a big community and a big amount of packages that can be used. It's really good for building object-oriented programming models. The second reason is the AnyLogic Cloud, which is really good for scalability. We used it for this project. It's also been very, very useful, especially in Petronas when we are building small use cases to be able to share those use cases very quickly with the business and get quick feedback. It's also been great for integration with our custom web applications. And also, even within the data science department, when we are running analysis, since it has the Python API as well, most of our data scientists, as I'm assuming elsewhere in the world, they work a lot with Jupyter notebooks, which has great integrations for creating plots and analysis. And again, you can do that with the Python API. Another thing, I guess, is that, as I was saying at the beginning, we've been developing models in many different areas. As I said, I didn't expect to be doing that in Petronas, but we've been doing even for pedestrians, right? So even one just to share one experience, when developing a pedestrian model and sharing this model to the business, or one of the guys asked, "Oh, is this showing like a real life of the pedestrians?" Which actually tells you how realistic the models can be. And finally, I think it's a great platform for building useful, beautiful, and engaging visualizations. All right, so that should be all. Thank you very much. And I guess I'll open the floor for questions. Let me stop sharing. All right, let's go with the first one. All right, so first question is actually on the visuals. So how did we make this? Actually, everything has been done in AnyLogic. I guess there is a bit of art and the ability of the modeler to make it look nice, but there's plenty of options to make it look like that. Again, the answer is it's done everything in AnyLogic. Yeah, asking if it's possible to have the presentation. I think so. Ryan will confirm that later, but I think so. Can AnyLogic manage geodistances independently to time delays? There's different ways how you can move an agent from A to B. Again, that's a question probably the AnyLogic support team will be better suited to answer this question. But you can create your own route, your custom routings. You can create custom paths and then give it your custom the time that you want, or you can base it on the distance, and you can just give it a speed, and then it will do the calculation for you. So there are many ways how you can move an agent from A to B in a map. In terms of distribution of delays, we leverage on historical data, and then we build the distributions from that. But just as we did for the lifting at the depots, the volume lifting. So again, we looked at historical data, tried to model a distribution that fitted that data. But another approach that we considered, and that was part of the conclusion slide, is to probably leverage on machine learning models, because each location has their own peculiarities. So there are better ways to predict the lifting at the different locations using machine learning models. How was the AnyLogic learning curve? Again, the fact that it uses Java helps a lot. There are many other softwares, simulation softwares, that do have their own language, which makes it difficult, because then when you are trying to search, for example, in channels like Stack Overflow, if it uses Java, you don't need to, it's not linked just to AnyLogic, it's linked to any other solution built in Java. But if you are using your own custom language, yeah, then it's only in your software that's going to be used. Critical levels. Well, I guess that was answering the distribution. Oh, the vessels moving into each other. Well, as you know, right, the simulation, maybe an advice, or that's how we build models in Petronas, is always try to model your system as a simplification of the real system. So always try to simplify as much as you can until the details that you are removing are actually relevant. So that should be the way how you approach a problem. So in this case, you're asking, why are vessels running onto each other? I guess that's something that it's not relevant at this point.